Problem number 8 on our Unit 4 study guide on differentiation is our first projectile motion problem. We're told we have the function s of t that represents the height of an object thrown straight up. The object was thrown with an initial velocity of 9.8 meters per second from a height of 39 meters. So our first step in solving this problem is substituting our initial velocity into v naught and our initial height into s naught. So go ahead and do that to get the equation. We should get the equation s of t equals negative 4.9 t squared plus 9.8 t plus 39, or the equivalent calculator version of that. So go ahead and graph it. You can start with a zoom fit for your window. That gets you a good view of the graph because you can see both intercepts and the vertex. But you could leave it like that, or you could zoom in on the money zone that we're going to be looking at, which is, of course, the first quadrant, the positive x and the positive y. However you want to do it, we can start answering these questions now. Question A asks us to find the time when the object hits the ground. So in order to do that, if you think about the problem, this function represents the position of the object, the height of the object, rather. So all we have to do is figure out when the height equals 0. That represents when the object hits the ground. So go ahead and do second calculate 0. Choose a point to the left of the 0. Choose a point to the right of the 0. Give it a quick little guess, and it'll tell you the 0 at that point right there. Or, like some of you like to do, you can go ahead and graph the line y equals 0 and calculate the intersection point between that line and the positive 0 on our graph. Whichever you prefer, do that and find that you get the x value 3.993, which, remember, our units here are seconds. So again, what that's saying is the object will hit the ground after 3.993 seconds. Now questions B and C ask us to figure out when the velocity is 0. Well, the velocity is going to be 0 when the object reaches its maximum height, because it's going to be going up, 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 up. Eventually it's going to stop, turn around, and then start going back down. Our velocity will be 0 at that point right there. So all we got to do is calculate the maximum value of this function on our calculator. We can do that. Okay, sorry, my dog's like having a seizure right now. Sorry, but no joke, that was crazy. She must be having a wild dream because like all of her muscles were spasming, so like her legs were moving, her like torso was twitching, her ears were moving, her facial muscles were moving all around, and even her like eyelids are moving, and they're moving right now too. They're moving back, but her eyes are still looking down. Super creepy. Sorry, that was a big distraction. Big distraction. I can't even talk. Big distraction. Okay, so velocity, find the maximum. So go ahead and do that, and we'll find that we get the 0.1, 43.9. I'm doing that from memory. Hopefully that's right. But again, interpreting this tells us that the velocity is 0 at x equals 1, or essentially the velocity is 0 after 1 second. It also tells us that the max height is 43.9 meters.